Good morning for another episode of Coffee and Compressed Air. So today I'm here with Maria. Is it Sandoval? Am I saying that right?
Yep, Sandoval.
Sandoval. Awesome. So we bumped into each other on LinkedIn. So I love that for us. And so I've got to know you just a tiny bit through there. But can you do an intro of yourself, just quickly, a little bit of background, and kind of what is your world right now?
Yeah. Um, like Danny said, my name's Maria Sandoval. I'm a lab professional and microbiologist by background with experience in quality systems. I've been in academic laboratories, regulated laboratories. There is a difference. A lot of academic laboratories are unregulated and a little wild, wild westy. Oh, that didn't work, so I'm going to try this experiment. Whereas regulated labs are beholden to some sort of standard.
Okay.
Um, and then the last 8 years was in compressed air quality testing.
Okay.
But yeah, we spoke a little offline about some of the interesting things we've done. So I think I'll give you a little tidbit. I've worked on fungal samples from the 50-kilometer exclusion zone from Chernobyl, right? So Chernobyl hit and then everything died because of the radiation. But as Jurassic Park says, life has a way. And so fungal organisms started growing. So it was my job to identify those, categorize those, and look for secondary metabolites, which are like antibiotics that could be isolated from those organisms. So that was little Maria. And then I grew up a little bit and went
Okay,
to,
that's insane. I need to
yeah,
stop
yeah,
you
that
there.
happened.
That is so cool.
Yeah, that happened.
That
Very
is,
cool.
yes, that is very cool. And I also am a fan of Jurassic Park as my
I love dinosaurs too,
so
Danny.
all of that. Okay, I can let you move on. Sorry,
Yeah.
I love
And
this.
then, then I got a little bit older, moved to MD Anderson Cancer. Before that, I was at the Department of Health working on tuberculosis samples from all around the United States. Because, as you know, it's highly contagious. So I was in the full level 3 PAPR suit from head to toe. Uh, don't be glamorized by Hollywood, folks. That thing is hot, it is uncomfortable, and when you have to use the restroom, it's a whole ordeal. So I did that. And then after that, I went to MD Anderson. I worked on cancer research. Um, and that was probably one of the most fulfilling mission driven jobs ever. But they moved from Smithville over to Houston, to the big medical center over there. And so at that point, I had just bought a house, so I wasn't going to move. So then I found a microbiology job at Trace Analytics, and that's where I had been for about 8 years.
Okay.
And that was doing quality for compressed air testing contaminants. So that's how I got here. But yeah, my world right now is I'm working on an MBA specifically in business analytics. And so from going from the lab, right?
Yeah.
We're taught find all the variables, find why this is going to break, and find a solution and do those things. But the business strategy world is very different. And I had a lot of holes to shore up there. I didn't quite understand why some business initiatives in a science realm were happening. And so I wanted to shore up those holes. And so that's why I decided to go get an MBA in business analytics. So that's what I've been doing for the last year. And I want to better like mesh those worlds together so
Mhm.
that we can make better compressed air quality decisions, things that are
Yeah.
efficient and reliable.
Yeah. That's insane. I don't even
Yeah.
know where to go with this right now because your opening is still incredible. I don't even wanna talk about compressed air anymore. I wanna talk about the other stuff.
Yeah, it's pretty cool.
Yeah, that is incredible. I love this so much. So before we Okay, so you can go way technical. So before we
Yeah.
even go near any of that, what do you do for fun? You're in Austin, right?
Yeah. So I live in, well, the metro city around me is in Austin. I live out in the sticks. I live in Bastrop County.
Okay.
So we just bought a house out here about 2 years ago. So, we've got some land. My dogs run on it. I have two dogs, two blue heelers, Otis and Ellie. They're like little velociraptors.
Yeah.
Very loyal to me. I don't see a problem. But, when my friends come over, they're like, lock those things up, man. And I'm like, fair, fair. Um, but yeah, so we've been working at the house for, getting the dead brush and all the trees cleared
Mhm.
out. And when I say we, I mean the royal we, right? I'm not doing these things. I'm passing out iced tea and telling Chris things like, that tree never stood a chance. You did an amazing job cutting it down. Go you. Um, so that's what I'm doing for fun. I also like to hang out with my friends. And occasionally you'll find me at a karaoke bar. I love to sing along. I am no good at it, don't get it twisted, but I have the confidence of a psychopath. So, I'm up there. I am winning American Idol when I'm up there, but it's not good.
Yeah.
But yeah, that's what I do for fun, kind of release some stress.
Oh my gosh. I love that. So, oh, we did get a fun comment. What a cool background. You do have an awesome background. I'm like, we can do a whole show just on that and like scrap everything we had to talk about today. Um, okay, so you have your biology degree and very, in a cool way, ended up in compressed air
Yeah.
quality. Like, so if you had to tell your younger self that's, where you would land, what would you say?
Danny, I would have laughed because I would have said, "You're telling me I'm going to work on compressed air, like compressed gas, the annoying thing that's inside my Doritos bag taking up space. Like there's no way. I don't understand. I don't get it. No." Because when you go into science, when I went into science, all right, look, I'm going to admit this in public radio. I
It
wrote my Nobel Prize acceptance speech when I was a junior in high school. I was like convinced. I was like, this is happening. Uh, so when you go into biology, you imagine that you're going to be, at least for myself, I was going to be in academic research,
Mhm.
diagnostics, microbiology, healthcare, some sort of environmental science, things like that. I never really imagined that compressed air gas was going to be this whole world of contamination control, quality system standards, and industry education.
Mhm.
I think you're getting a vibe that I enjoy talking. I enjoy talking about this topic. Um, so I wouldn't have imagined 20 years ago that I would be this excited about compressed air and compressed gases, but I am. It sparks joy.
Yeah.
I've been out of the game for about a year focusing on my MBA. But, a year ago we had met and I was like, Dr. Rakova was talking about her ISO standard on the
Mhm.
compressor side. And I was like, we got to talk about quality. And she's like, no. I was like, yes, 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 yes. Let me talk about it. And you were like, well, let's talk about it. I was like, okay, call me in a year.
Yeah.
And, here we are today. So genuinely enjoyed talking about it.
Yeah.
And it actually does make sense. My science background's trained me to think about like invisible risks, and that is what compressed air, right? There is
Mhm.
invisible risk, particles, water, oil. You can't see these things when the air is expanding and when it's being shot out of the point of view. So
Mhm.
yeah. I think 20 years ago, Maria would be surprised and hopefully pretty proud.
Yes. I love it. Well, some other people at least think it's fun. We at least have 2 comments now. Anne said, "I agree. Great to combine science with business," which I agree also because, like you said, there's such a big gap. I mean, business is I feel like so complex, and then you bring in, like, you start talking science. I can actually understand a little bit because I started with my degree in biology.
Yeah.
Um, but then they said if I stayed there, I would have to dissect a cadaver, and I said, "I can't do that." Uh, I said, "For this reason, I am out. I will study wildlife sciences and
There you go.
dissect lots of animals," but I could
Yeah.
not get past that
Yeah.
part. And they're like, "That's not till your last year," and I said, "I know it's I can't even." Like, my three-year-old says, "I can't want to do that." Like, I can't
Yeah.
want, not that I, like, won't do it, I just
Yeah.
can't want to do that.
Yeah. I
So,
get you.
yeah, so but it's very complex, it's very interesting, but we'll transition a little bit since this is coffee and compressed air. We will go into some of this compressed air stuff because you said some already really important stuff, and we haven't even got into it yet, especially like when you think about all the things that are made that we are purchasing, we as in like all people, with access to a grocery store, a pharmacy, a Walmart, where your clothes, your bedding, everything, compressed air literally touches all of it. And when you go inside these factories or just go on YouTube and see how it's made, a lot of it's touched by toothbrushes, that one was a big eye opener when I went to my first toothbrush manufacturing facility. I had no idea that process. Like, I'm like, "Oh, these things don't magically appear in the store."
No,
Just
they
assemble.
have to be molded. How about
Yes,
that?
yes, and, so that was a big eye opener for me, and then even package how our food gets. I actually worked at a food processing plant, so in quality. So, like, I got a deep dive into that, for a quick year, and it's a lot. So I think, like, this is actually more important to the general population even, like, what is touching things that they're using every day.
Yeah, I think that's a great place to start. And I think we can even take a step back for a second and think about what is compressed air. It sounds harmless, right? It's just air. But when you think about what it is, when you compress ambient air, you change the risk profile. And so that statement right there
Mhm,
should shock people, right? So you have ambient air. When you compress it, you change the risk profile, which means that you have to make a cognitive choice to think about what you're going to use it for. And so, why is that? So, you're taking the air around you. It's already got moisture in it. It's got vapors in it. It's got, you can smell things in the air. Sometimes there's moisture. If you're in Florida, you can feel the humidity.
mhm,
All of these things are in the air, particles, water, oil. And so when you compress it, you're concentrating all of those, and I'm going to use contaminants, all of those contaminants way down into a per square inch um, volume. And so then on top of that, the compressed air system itself can add contamination, right? So now you've got the stuff that's in the ambient air,
mhm,
and then whatever could be in your plumbing system, whatever could be in your filtration or the end point of views. So you
mhm,
can have moisture from condensation, you can have oil carryover from compressors, you can have particles from piping or filters, microbial concerns in wet areas, even contamination from poor maintenance, or even um, aging components. So I've seen areas in the Northeast that are older buildings, right? And they have older piping, and they think, okay, well, I'll come in, we'll change the compressor, we'll keep the piping. But it's like, oh, you change the storage tank, but then it's getting pushed through the old piping, so
mhm,
you're still contaminating it potentially. So
mhm,
compressed air, it's not just air, it's a process utility. This is ambient air that has been processed into a utility. And depending on where it's being used or what products it's touching,
mhm,
um, it can affect product safety, it can affect system performance, customer satisfaction, even brand recognition.
Mm.
all of those things it can touch.
Wow.
Yeah.
Wow. Yeah, that's I like the way you frame that. I don't think I've ever heard anybody say that it's ambient air that is processed. Like we know this, but I don't think I've heard anybody actually articulate that in such a way. So I think that's leads us straight into the next question, which is okay, so now you have this stuff in there. Like, are people losing sleep over this, or it's just business as usual? Like you mentioned the particulates, the moisture, the oil. Like, can you just break down like I'm 5 what what that is?
Yeah, no, absolutely. Okay, so now it's time to talk about ISO 8573.
Yeah.
Let's real quickly. ISO is an international standard organization that creates a universal way for everybody to be on the same page.
Mhm,
ISO 8573 is specifically for compressed air and its contaminant measurements. So the big three in ISO 8573 is particles, water, and oil. We'll talk about what that looks like in a little bit, which is like 111, or you'll see, hey, our filter can meet class 000. Just know when you hear a number, and a number, it's particles, water, oil, PWO.
okay.
And so particles are the physical contamination. We're talking about non-viable particulates, dust, rust, and then we're talking about viable particulates, bacteria, yeast, mold. Those are still particles. And so when they're combined, they make the summation of the particle contamination. And you can get it from, like I said, microbes. You can get it from dust, pipe, scales, filter debris, anything solid moving through the airstream.
Mhm,
And then when particles go wrong, so you ask, like, who cares about this? Well, when
mhm,
the particles get too high, or the concentration is too high for your point of use, they can clog your valves, they can damage instruments, they can block nozzles, they can affect your sensors, they can end up on your final product contact surfaces. So anyone using compressed air for packaging, electronics, instruments, food, contact, pharma, medical devices, anything that's precision manufacturing should care about particles in that way. And then you have the fun one, which is moisture, right? Everybody thinks, oh, we drained the condensate. It's okay.
mhm,
It's probably one of the most underestimated problems that you see. And compressed air systems naturally create condensate, right? When the air is compressed and then it cools down, the water drops out. So if moisture is not controlled, you'll end up getting corrosion. If you don't get corrosion, or you do get corrosion, then you can have microbial growth risks. Um, we could do a whole podcast on microbials, growth
mhm,
risks, and their biofilms, and why microorganisms can actually build pyramids to make themselves more stable in a biofilm. It'll blow your mind, but we're not going to do that today. But yeah, so moisture is a big deal. And anybody, it's important for anyone, right, who has long distribution lines. We're talking, and you've been to a toothbrush place. So I'm sure they had miles of distribution piping. It and that means there's a lot of cooling, a lot of dropping out, condensate can occur. Anybody with outdoor plumbing, sensitive instruments, again, the food applications, stuff like that. And then you have oil, which is another major one. So oil is not just liquid oil, there's also oil vapors. So you can have oil vapors, liquid oil, and those come from lubricated compressors, maintenance issues, hydrocarbon vapors that are in intake air. One of the It's not necessarily a pet peeve, so don't really come for me. But the term oil-free compressor is a little bit misleading, only because yes, there are parts of it that are oil-free, but the pistons, those things have to be lubricated, and there is a form of oil, a lubrication that is in the system itself. So
mhm,
you always do have to be mindful of hydrocarbons and oil contaminants and things like that. And so the same types of people who care about particles in water are still caring about oil. So
Mhm.
simply, you want to think about it as particles damage, moisture corrodes, and oil coats and compromises, right? And
Mhm.
so, the people who are losing sleep over this are typically quality managers, but it's also maintenance people, right? It's the people who are changing out the consumables. It's EH&S leadership. It's the people who have to sign the purchase order. I mean, a lot of these aftermarket parts are not necessarily cheap. So yeah, those are the people who have to care about it.
Yeah, I always even I mean, I've been in compressed air for, over 10 years now, and I've always found it so interesting that this is the one thing that touches almost all departments in the manufacturing, like, not from the operators to maintenance to safety, to directors all the way up, like, it legit has to have everybody sitting in the room because it affects quality, performance, everything.
Yeah.
Um, and then now this is just another addition to what I had already figured out. Um, so so you touched a little on the one-to-one-to-one purity class. Can you
Mhm.
go into what those actually mean? I know that now it stands for the 3 different like the oil, the water.
hmm
Um,
So let's talk about 111. Everybody thinks, oh, it's 111. It's the highest purity class. It's what we should aim for, but that's not necessarily true, right? A
mhm,
111 purity class sounds simple, but each number represents a different contaminant under ISO 8573-1. There are 9 sections. Dash 1 talks about the purity classes, how to meet them. And then section 2 through 9 talks about the test methods that can be used by a laboratory to meet the purity classes. Um, so the first number is particles, the second is water, the third is oil. And
mhm,
so when someone says 111, they're saying they want very clean compressed air, very dry or very clean for particles, very dry for moisture, and then very low oil contamination. So often it's treated like the gold standard because it's one of the strictest commonly referenced purity class combinations. But
mhm,
that does not mean that every single business needs to use it. Honestly, there needs to be where companies, this is kind of where companies get a little bit into trouble because the cleaner air is not always the smarter option if
mhm,
you don't need it, right? It should all be based on actual risk assessment of the final application. So if compressed air is touching pharmaceutical products or food, anything that comes in contact with surfaces that are going to be used, medical devices, things like that, then a stricter purity class does make sense. But if you're using it for like a general purpose, something that's non-critical, then you don't necessarily need 111, right? So you don't need to spend all that money on aftermarket filtration or things like that for that point of use, right?
mhm.
You could be spending more on drying, filtration, maintenance, pressure drops, and energy than you actually are required to spend for that point of use. So just, that's something to be mindful of when you hear 111. Sometimes the best purity class is not always applicable to the point of use that your company is using.
Wow, very interesting. I still have a couple more questions, so we're gonna keep going because I
Yeah.
love this conversation. Let's see, we do have some more comments. So Felipe said, "Oil-free piston compressors, what parts are PTFE coated?" I don't know what that means. I'm gonna just put that out there.
Yeah. So
Good for tech.
PTFE is a composition. Um, and so here's the thing. I use it as an example, but there are all kinds of lubricants that can occur. And when there's a combustion in an engine, which there is for a compressor, there is heat and then there is a cooling off, and so there's a compression and an expansion thing that's reaction that's occurring. And so then you can have an off gas of PTFE, you can have an off gas of all these things. And so those are the types of oil contaminations that can potentially be seen later down the line. That does not mean that they are seen, but it could be seen. And so that kind of takes me into the last like thing that I wanted to say is, in order to say that you have 111 air, or to say that you have a certain purity class, you can't just do it one time. There
Mhm.
has to be a sense of monitoring. So you have to test, right? How you choose to test is something that is guided to you by ISO 8573. Like again, there's a whole nother pocket of people that deal with the aftermarket filtration, that deal with the columns, that deal with all the media that goes into the columns. That's that. But for contaminant testing, this is ISO 8573.
Okay. Okay. So we're gonna have to, I'm sure we could talk all day about this stuff, and I'm very
Yeah.
interested in all the questions. But for time's sake, I do want to touch these last questions because
Yeah.
I'm so interested. Back to the microbiology side, because I study this for a little bit, and a lot of people haven't actually seen a lot of these microbes under, like, an actual microscope. They're moving. Like, they have, like, little they're not legs or anything, but they're like they can move, and some of them look crazy, like, and, like, just so many things going on under a microscope that you literally cannot see
Yeah.
looking. So, I wanna talk about that inside compressed air. Can those things move and, like, grow and multiply? Yeah, I'm gonna let
So
you, because I really want.
this is one of my favorite topics, obviously, because I have a microbiology background, and I was fortunate enough to be the project leader for rewriting ISO 85-7, which is the microbial contamination standard. So why do I love this question? It's because the microbiology side of compressed air, is often invisible until it's a problem, right?
Mhm,
People tend to think of compressed air as dry and it's hostile, so nothing can live there.
mhm.
But people live in Arizona. Just kidding. But compressed air systems are not always dry everywhere.
Yeah,
Anywhere you have moisture, you have warm temperatures, stagnant areas, biofilm potential, or poor drainage, you can create conditions where microbial contamination can occur, and it can be a real concern, right? So if you don't believe me, you go ask the person who does the maintenance for your points of use, and ask them if they've ever exchanged piping or any of the consumables, and if they've ever felt something kind of slippery, maybe a little oily, maybe a little like shiny.
mhm,
And oftentimes that is a biofilm. Not always, but oftentimes. And so what can show up? You can see environmental bacteria, you can see mold spores, you can see yeasts, all these types of organisms that are common in the ambient air,
mhm.
common in water, soil, and facility environments, things like that. They can enter through the compressor intake, get compressed down. You remember I said it gets compressed down, it gets hyper concentrated, and then it can go downstream into your condensate and contaminating your piping, tanks, filters, hoses, points of use, things like that. One of your questions was like, can it grow? Yeah. Here's the thing, though, is let's talk about Jurassic Park again, right? Where life has a way.
Yeah,
If the organism is not happy, and it is if the bacterium if the bacteria is not happy and it is a specific strain that creates spores, what it'll do is it'll say, look, it sucks in here. The pressure's too high. I'm hot. I can't do this. I'm going to put all of my DNA instructions into a luggage, and I'm just going to hold this luggage for a while. I'm not going to replicate. I'm not going to do anything. I'm just going to like go with the flow. Then it exits your point of use, it hits a loaf of bread, right? Because nobody is hand opening a bag to put your loaf of bread in. Okay. Nobody's doing that. They're using compressed air to blow the bag open to slide your loaf of bread into there. So when that loaf of bread touches that spore, there's ambient air, mixed with the compressed air in there, and then the spore goes, all right, it feels pretty good in here. There's some sugar, there's some,
Oh,
it's a little bit warm, and then it's like, all right, cool. I think I'm gonna replicate. All right, so I'm gonna replicate, and then that's how you end up with mold on your bread, but or that's how you end up with spores replicating, things like that.
yeah.
Um, but the point is that the spore is in your pipeline. It is in your point of use. It can be, right, if you have that type of bacteria in there. But you will only know if you test. You won't know if you don't test. And you will only know if you test for viable contaminants. You won't know if you use something like a laser particle counter that only tests the totality of particles, right? It's not going to tell you if it's viable or non-viable. So, yeah, it's a good time. You have to be careful you don't scare yourself.
Did you see my face already? I'm like, I am gonna have
Yeah,
to
yeah,
start up my sourdough again.
yeah, yeah. I refuse to do that, by the way. I'll just eat the sourdough. I'm not trying to put my hands in that.
Oh my gosh. I love this so much. Um, yeah, well, we're at 30 minutes. It didn't even feel like 30 minutes. I feel like we just started, and I have more questions now than when we started.
That's okay.
Um, okay. For anyone listening right now, if people are still here listening to us and they work in compressed air or work in manufacturing even and don't even know they use compressed air, maybe if they sit in an office somewhere, what is the first thing they should do if they want to understand, like, if they have any of the stuff we just talked about in their system? Like, what's step one besides asking somebody?
Yeah, so the first thing you want to do is you want to map your compressed air. You want to see where the piping distribution is going. You actually want to see how it's being used in the facility before you order testing, before you buy any filtration to make it better or not, or hey, it's overkill. You want to ask, where's the air going? What does it touch? What product does it touch? Let's do a risk assessment.
Mhm.
So once you understand the points of use, you can start assigning an appropriate risk. Once you know the appropriate risk, you can assign an appropriate purity class. Not every compressed air outlet needs the same purity class, and not every sample point needs to tell the same story, right?
Okay.
So the compressor room may tell you something about the system generation, but the point of use is going to tell you something that is what is occurring in the process after it's being received. So if I had to say anything, I'd say probably this week I would tell someone to do three things: walk the system, identify the framework to define the purity class.
Mhm.
That makes sense for particles, water, and oil. And then the goal is not to test randomly. The goal is to test intentionally, right? Start with your highest risk points, define what clean means for those applications, and then verify whether or not your system actually needs to deliver that quality. That's what I would
Mhm.
do.
I love that. And I should end there, but I have one more question. I could probably ask it offline and not have my husband be able to see this. I have lots of plants in my house, and I tell
Okay.
myself they clean the air. Is
Yeah.
that real? Because
They,
that's
I mean, they can. Here's the thing, too, though. Plants are living organisms,
and
Danny.
yes,
Do you dust?
I
Do you dust your plants?
I do, and I have the, neem
That's
oil,
good.
like, I
Yeah.
spray them, they
Yeah.
get cleaned,
Then
all
yeah,
of this stuff,
they're definitely
and in
exchanging your CO2 for oxygen.
okay,
They're doing that.
I could take a
You
deep
got
breath.
some lights on there, so they're photosynthesizing.
Oh, yeah,
Uh, yeah,
yeah,
yeah. The
my
biggest thing though is making sure you dust your plants, right? They
yeah,
need to breathe too. They have pores also, so you have to make sure they don't get clogged. They
yes,
like to have a
yes,
clean,
my leaves are
clean
not
face. They need to be exfoliated,
yes,
Danny. Exfoliation.
they oh, mine are. My plants are a little spoiled. We'll let them go a little longer till they're drooping. I'm like, "Sorry, I ignored you.
Yeah, no,
Let's
that's me too.
do a full refresh." But that's my selling point to my husband, why I keep them.
Yes.
They're a job. I mean, they need things, obviously, and then, of course, if I put too much water in there, then you get mold, so, like, that's a whole 'nother like,
Yeah, you didn't even want to talk about the gnat situation.
yeah,
Ugh.
yeah, mine are pretty good, but I will sacrifice a plant in the name of not having anything in my I know, like, you're getting dunked if you don't survive,
Yeah,
survive, like, you're
I feel
getting
that. Yes.
yes, 'cause my sanity comes first,
Yes.
okay, so yeah, thank you for that. Uh, that was a random. So one more question on here. Uh, do spores survive class 1 or 2 for water?
Yeah. Remember, spores are not necessarily affected by very many external conditions. They can be destroyed in an autoclave under pressure and high temperatures, but it all depends on what your pipeline temperature is. It all depends on your point of use. But again, if you're truly concerned about it, the best way to test is to test your microbial contaminant.
There we go.
Yep.
Let's see. One more comment. Not only point of use, air leaks can contaminate everything within an enclosed production line, even without a direct point of use.
Yep. Absolutely. Air will get sucked in through the leak, and then
Mhm,
you can have corrosion there. You can have biofilms build out there. Moisture enters. Yeah, leaks are a big deal. But
mhm,
that's something that Dr. Rakova's system, determining whether the efficiency of the pipeline is working, the flow rates, things
mhm,
like that. So that's when you want
mhm,
an aftermarket system that can monitor that.
mhm. Yeah. Yeah, I feel like you between you and her, you guys are tackling, like, this one big beast, and this is, like, a whole 'nother big beast, even though it's in the same system, like, yeah.
Yeah.
Yes, big, big beast to be dealt with, here, but thank you so much, we did run a little bit, but people are still listening, so
Awesome.
I'm still listening.
Me too.
I have so many okay, well, if there are any more questions, feel free to put them in the comments, and Maria, it has been such a pleasure. I knew this was gonna be a fun one just based on our back and forths, prior to this. So
Yeah.
thank you so much, and you made this so much fun. Like, science and business are sometimes not fun or lighthearted, like, they're all very, very serious, and they are serious, right?
They are.
They can have very serious effects. But just to make people more aware, I think this is, like, one of the ways to do that, to, bring the awareness, this
Yes.
way and not, like, with an AI sheet that says this
Yeah.
stuff.
Yeah.
Well,
I agree.
people, I love this, and thank you so much. We'll go ahead and end that for today, but I'm sure we might get some, comments or DMs. Feel free to reach out and ask any questions, but thank you, everyone.
Awesome. All
Thank you,
right. See
Maria.
you later. Bye, guys.